Hey everyone. I just wanted to do, before we started the lesson for today, just clarify a couple of updates that you may or may not be aware of. So we're going to talk through some changes that you're going to see and how this class has been designed for quarter four, and then we're going to get into the lesson for today. So first things first, as you may have heard at this point, the Regents for June has been canceled. Now, as to what that means about your Regents credit, we still aren't sure. As soon as I know, you will know. But for now, the plan for physics is that we're going to create an alternative final. You're going to take that final, obviously at the end of the year. And we will still be doing labs, but there will be no lab minute requirement anymore because the lab minute requirement was in part to fulfill that 1200 minute requirement for the Regents. So we don't really have to worry about the minutes anymore. I'm not going to be tracking them. However, we still will be doing labs because I feel like they're a very easy and approachable way of piecing together some of the material that we're going to be learning for the rest of the year. So that's basically all of Regents. Now, a couple of grading scale changes that I want to highlight. I broke down how the new grading scale is going to be here in this pie chart. The biggest changes that you may or may not notice is that we have changed the weight of your homework and classwork. Previously, when we were in school, your homework and classwork was worth about 20% of your grade. Obviously now, in your day-to-day for remote learning, a lot of what you're doing for me is your homework and your classwork. So that's going to be worth double, and it's going to be a very impactful part of your grade. So it's going to be in your best interest, if you have not been great about consistently doing homework, to kind of start doing it. Now, your homework and classwork will be broken down into two portions. Your classwork will be Edpuzzles, and those will be graded on completion. Now, the idea behind that is that I want to give you a chance to kind of practice the stuff that you're learning in the moment without feeling the pressure of like, oh man, I have to get everything 100% right. That does mean, however, that your homeworks, which are Google Classroom, and you've already seen a few of them at this point, those will be graded on accuracy because I want to make sure that you are putting your best foot forward and getting the most that you can out of that homework assignment. Another thing I want to highlight, tests and quizzes have been combined. Traditionally, tests and quizzes were different sections in the gradebook. Now that we are combining them together, what that means is that quizzes are actually going to be a lot more impactful on your grade, because before you might be absolutely destroying quizzes, killing it, but then you would bomb a test and your grade wouldn't really change if you did well on more quizzes. Now, doing well on more quizzes is actually going to raise your test grade because they're combined, so keep that in mind. Now, last thing I want to highlight, or second to last thing I want to highlight before we get into the lesson for today, is how important it is going to be to complete work on time. Now, I was pretty flexible this last quarter on late homework. For a lot of you, like if you were clear and communicated with me, like, hey, something's going on, or even if you weren't that clear and didn't communicate that much with me, I was pretty flexible on late assignments. But now I want to put forth a very strict schedule just so you have an idea of how assignments are going to work for me. So homework will be uploaded Monday, Wednesday, and Thursday by 8 a.m. Now, the reason I say by 8 a.m. is to give you a chance to complete it by the following day at 11:59 a.m. That gives you 16 hours to complete a homework assignment. So that means that if I assign something Monday, it's going to be due Tuesday. So if I assign it Monday, due Tuesday. If I assign it Wednesday, it's due Thursday. If I assign it Thursday, it's going to be due Friday. So those are the connecting values. The connecting dates, I should say. Last thing I want you to keep in mind here is that if you start to feel overwhelmed or have something else going on at home, you need to communicate. I know these are weird times, so you need to be flexible. I don't mind being flexible, I should say, as long as you are communicative with me. If you let me know what's going on, I can definitely help you out. Otherwise, you may either get partial or no credit for late assignments. So keep that in mind. Last thing I want to talk about is a tutoring schedule. I've been approved to use Zoom now, so we can have Zoom calls for just our class. I know for those of you that participated earlier, it was myself, Mrs. Petruzziello, and Ms. Guerra in a room together with all of their students and all of your classmates as well. Now it's just going to be our classmates and probably myself and Ms. Guerra sitting in the Zoom call, waiting for any questions. They're going to be an hour long. I'm aiming for 10:30 a.m. I feel that's a pretty reasonable time to have a tutoring session. The reason why I want to do 10:30 and an hour long is so that you have chance to check in with me from 10:30 to 11:30 about anything that you're confused about, and that still gives you about a half hour to complete your homework before it's marked late and you might lose points or not get any points at all. So 10:30 is the time that I'm aiming for. If there's like big concerns about that, please let me know. Text me, email me. Big concerns does not include I don't get up until 12 because that is a you problem and not a me problem. I think that's pretty much it. So we can get started on our lesson for today, and we're going to talk about today about something called Ohm's law. Now, I've revisiting this image again for possibly the third time, I think, and it's because I feel like it really encapsulates what we've been learning the last few days in a really efficient way. So we've talked about ohms, we've talked about amperes, we've talked about volts, and I just want to re-identify what all of those things stand for and mean. So we know that current is measured in amps, and that's just the charge going through the wire. You don't have to write this down because I've already shown it to you in a PowerPoint before, so you should already have this in your notes. If you don't, feel free to pause the video and write what I'm saying down. So current is what we call like the electricity. It's what's actually flowing through. It's what's made up of electrons. Resistance, which is measured in ohms, is restricting or slowing that charge down. We talked about resistance last week, or the week before break, I should say. We talked about the different factors that can affect resistance, the length of a wire, the cross-sectional area, etc., etc. And voltage, or measured in volts, is the push that is forcing the current to go through. So we think about voltage when we talk about like batteries, because batteries are providing that voltage that allows for that current to kind of go through. It provides that work needed to force that current through a certain distance. Now, before we can continue talking about circuits and understanding how they work and what Ohm's law helps us calculate, it's important to recognize the different tools that we can use to measure out some of the values that we care about in Ohm's law. So the first thing I want to highlight here is that we have an ammeter and a voltmeter. So an ammeter is an instrument used to measure the current in the circuit. Now I want to remind you that current is referring to I, which is measured in amperes. When you draw this into a circuit, you use the symbol from your reference table. Remember, this is all on your reference table on the electricity page. And ammeters are on the actual path of the current. They are drawn into the circuit. So what do I mean by that? Well, to show you, let's draw a simple circuit. So I'm going to draw in my battery. I'm going to draw in, let's draw in a resistor here. And let's complete the circuit. And remember, this is just kind of wire. This is the resistor. This is my battery, so it's where my voltage is coming from. Now, when I say that they're drawn on the path of the current, well, the path of the current is the wiring, whatever is running through the wiring. So we want to actually draw the ammeter on the path of the current. So we might pick something like right here to draw. You could have drawn it right here if you wanted to, but as long as it is on the path of the current, that's totally fine. That is a correct place to put an ammeter. Now, voltmeters are a little different. They're instruments that measure the potential difference in a circuit. Now, I want you to remember that potential difference is just a different way of saying voltage. So we are using voltmeters to measure voltage. When drawn as part of a circuit, you use the symbol from the reference table. It's just a V inside a circle. Now, voltmeters are a little different than ammeters in how they're drawn. Voltmeters are drawn outside of the circuit in order to measure the distance traveled. So what do I mean by outside of the circuit? Let's draw the same very simple circuit that we drew in the first example. The only difference is now I'm actually going to include the ammeter now, because why not? And again, we draw the resistor right here, and we complete our circuit. And remember that this is where my voltage is coming from because it's my battery. So to kind of add in this voltmeter, it's got to be drawn outside of the circuit. So it can't be in the actual path of the current. It's not going to have any current flowing through it. So the way we do that is we can kind of just attach it to the outside, something like this. And we have the the voltmeter. So now you can see that the voltmeter is outside of the circuit. It isn't in that original path where the current is flowing through, but this is how we get it to measure voltage. So the first thing I want to ask you here, and I want you to take a couple seconds to answer, is this circuit, and just to be clear, the circuit refers to this portion, not this, not this, just the section that is starting at the battery and ending at the battery. Is this circuit in series or in parallel? Take a second and answer that. If you were careful and were paying attention, you should have noticed that this is actually in parallel. Now, the follow-up question I want to ask you is, where can we properly attach an ammeter? Keep in mind what the rules were for attaching an ammeter that we just talked about on the last page. Take a second and answer that. What positions could we position or attach an ammeter? So if you answered this question, you should have gotten that the ammeter can be placed in either 1 or 2. These are both completely acceptable places to add in that ammeter. And again, the reason why is because both of these positions are on the path of the current. Follow-up question. Where can we properly attach a voltmeter? Now keep in mind, how is a voltmeter different than an ammeter? Take a second and answer that. So very similarly to how we rationed out ammeter or reasoned out ammeter, you should think about the voltmeter as places that are outside of the circuit. So the circuit, again, is wherever we're running the actual current. So all the way around here, through this resistor, over here, or through this resistor, over here. So the correct places to place a voltmeter, and I'm actually going to change the color for this. The correct places to place a voltmeter would be either option 3 or option 4. And again, that's because they are outside of the circuit. Now, let's go back to Ohm's law. So the first thing I want you to keep in mind is that Ohm's law, the more traditional way that it's presented to you is right in this format right here. It's presented to you in the R equals VI. That's how it shows up on your reference table. Now, Ohm's law helps us understand the relationship between resistance, voltage, and current. And there's two relationships within Ohm's law that I want to help you highlight to kind of better understand how this kind of operates. So the first one is that resistance and current are inversely proportional. The second is that voltage and current are directly proportional. We'll come back to this idea in a little bit when we graph these relationships out, but for now, I just want you to write this down. You can pause the video if you need more time to write everything down. Now, I know a lot of you are really good at manipulating formulas to get whatever variable you need to solve for, but in case that's not really your strength or you don't feel super comfortable with it, we have what we call the Ohm's law triangle, the Veer triangle, whatever you really want to call it. And this is meant to help you understand or help you reformat this formula quickly to solve for any of these three variables. So let's say that the question was asking you to solve for voltage or potential difference, as it's sometimes called in a lot of our formulas. So if you were being asked to solve for voltage, what you would do is either use your thumb to cover up the V. I like crossing out the V because I know it's not relevant anymore. And that tells me that to get voltage, that's going to be equal to the current times the resistance. So just straight across, and that's what I would write down. If I were being asked for the current, if I were being asked for I, then I would do cross out the I, and that leaves me with V over R, and that's what I'm writing in here. And finally, if I'm being asked to solve for resistance, well, I would cross out the R, and that would leave me with V over I. So again, it's just meant to be like a quick trick to help you reformat the formula quickly. If you feel comfortable doing that without having to do all this, then feel free, you don't have to. But I'm going to show it using this method in case you feel like you need the help. So the last thing I want to address before we go into some math practice is what does this look like graphically? What does Ohm's law look like graphically? So in order to better understand this, I'm going to redraw in my triangle. So I've got the triangle here, I've got V on the top, I've got I here, and then I've got R here. So I'm being asked to draw voltage versus current. Because voltage is the first thing mentioned, I'm just going to cross that one out or use your thumb to cover it. And now I know that to get voltage, that's going to be I times R. So let's take a look at what's happening, right? If I increase voltage, how's that going to affect my I? Well, you should be able to determine that this is a direct relationship. As one increases, the other will increase. And so what that means is that this should actually show an increasing relationship. Now, is it going to be a straight line or a curve? Remember that curves only really come in when we have squared or square root or something like that, but there's no squared here, so this is actually going to be just a straight line. That's as straight as it's going to get, but it should be a straight line in your notebook. Let's take a look at the second example now, resistance versus current. So as I increase resistance, what happens to my current? Okay, so, or as I increase current, what happens to my resistance? So again, let's draw out my triangle. V, I, oh man. Oh, just kidding. Don't want to end this. Whoops. Okay. So, sorry guys. Okay. So let me just redraw in this shape right here. Should be a straight line that way. Again, I'm redrawing in my triangle, and that's going to be V, I, R. So I'm going to cross out resistance because that's what I'm being given first. And so I know that resistance is equal to V over I. Now, let's think about it. What happens if I increase I? How is that going to affect resistance? Well, this is an inverse relationship. As this one goes up, we're going to divide by a bigger number, which is going to make the R go down. And so the way that we draw in this is actually going to be the opposite. As one increases, the other should be decreasing. So we're going to draw a straight line going down. Again, this should be a straight line. This is once again an inverse relationship. Okay, so let's take a look at the first example doing some of the math here. The current through a 10 ohm resistor is 1.2 amperes. What is the potential difference across the resistor? A couple of things I want to highlight here. So let's get this in color. So we're being told that we have a current 10 ohm resistor, 1.2 amperes. So I'm seeing values for resistance that is 10 ohms. I'm seeing a value for current, which is 1.2 amperes, and I'm being asked for potential difference, which if you're being careful, you should recognize that it's just a different way of saying voltage. So I'm solving for voltage. I don't know what it is. At this point, if you feel comfortable reformatting R equals VI, then feel free. V over I, sorry, then feel free. If you don't, then use the triangle. And the triangle here, again, I'm being asked to solve for V, so I'm going to kind of either use it or cover my thumb with it or cross it out. And I know that V is going to be equal to I times R. And that's going to give me 1.2 times 10 to give me 12 volts. That is my answer for number 1. Number 2 is a little more involved, it's a little more difficult. So example 2 tells me that a 20 ohm resistor has 40 coulombs passing through it in 5 seconds. So we're being told that we have a 20 ohm resistor. Let's write that down. The resistance is 20 ohms. Now, we want to be careful here because we're being asked for potential difference again. So again, that's voltage. But I'm going to freeze here for a second, and I want you to think about what is different in example 2 that we didn't see in example 1. Take a second and answer that. So if you were looking at the numbers carefully and looking at the units carefully, you should have recognized that we're given the coulomb value here. Now, coulombs measure charge, which we use Q to symbolize. And obviously, seconds are a measurement of time. So here's the problem. We're being given R. We're being asked for V. We're given a charge, 40 coulombs, and we're given a time, 5 seconds. Now, we're given all this information, but we don't have a formula on the reference table that allows me to take resistance, charge, and time and solve for voltage anyway. But we do know that we can solve out for voltage if we have resistance and current. So that's just the R equals V over I that is on my reference table. So this is actually going to be a two-step problem. In my first step, I'm going to want to solve out for my current because I know from the week before we left for break that to solve for current, I take the charge and divide it by the time. This is going to be 40 coulombs divided by 5 seconds to get 8 amperes. Now, for the second portion, again, if you feel comfortable reformatting, feel free. If you don't feel comfortable, use the triangle. Now, if I'm being asked again for voltage, I can cross that out. That's what I want to solve for at the end, and this is 8 amperes. That's what I want to solve out for at the end. I know that V is going to be equal to I times R. I know that I is 8. That is a parentheses. R is 20, and that's going to give me 160 volts. Okay. So that's everything for today. Your homework is going to be 6 more practice problems. Make sure you list out your givens and determine which equation that you want to use to solve. It's going to help you a lot. Wednesday and Thursday, we're going to keep talking about Ohm's Law, but we're going to introduce something called the complex Ohm's Law. Aside from that, I hope everyone is staying safe. Please feel free to email or text if you have any questions. And yeah, have a great rest of your day, guys.